Hello students, welcome to today's class. Today we will study a very interesting topic of mathematics, and to be more precisely of calculus, which is called derivative. And to make this topic more interesting, we have to draw some picture. That means we have to apply geometry to it, and we have to study derivative thoroughly through geometry. Okay, fine. Okay. So I assume that you guys already know that what a straight line looks like in a Cartesian plane. Cartesian plane means if this is the origin and this is horizontal axis we consider as x-axis, vertical axis we consider as y-axis, then and this is negative x-axis as well as this is negative y-axis. Then a straight line looks like in Cartesian plane is this. This is a straight line, and this straight line makes an angle, let the angle be theta, with positive x-axis. Okay, I think you all guys already know that what is positive x-axis and what is negative x-axis. We will mainly focus on the angle which is made by the straight line with positive x-axis. We don't consider the angle made by the straight line with negative x-axis. Okay, what is the angle made by straight line with negative x-axis? This is the angle. Negative straight line, negative x-axis is from right to left, and positive x-axis is from left to right. So this angle is made by the straight line with positive x-axis, and this angle is made by the straight line with negative x-axis. We don't consider this angle. We are focusing only one angle, which is theta, which made by the straight line with positive x-axis. Okay. Then what is tan theta? Tan theta equals to slope of the straight line. You guys already know that, na? So tan theta equals to slope of the straight line. If a straight line makes an angle theta with positive x-axis, then tan theta will be the slope of that straight line. Now we have to find that the value of tan theta. Okay, what geometrically what tan theta gives, we have to find that, we have to calculate that. Okay, so to study the slope of the straight line geometrically, we consider a point P. Since the point P is in Cartesian plane, xy plane, so there is a x coordinate and as well as y coordinate. Okay, and we consider a point Q very near to P. We consider a point Q which is very near to P. Okay, and if this the point Q is very near to P, then the coordinate of Q is going to be something we called x plus means that the x coordinate of Q and the y coordinate of Q are not very separate from x and y. If coordinate of P is x comma y, x coordinate of P is x, y coordinate of P is y, then the x coordinate of Q is slightly deflected from x from the x coordinate of P. Okay, there is nothing to be more changeable. So we consider the x coordinate of Q is x plus del x and the y coordinate of Q is y plus del y. So there is minimum change in the x coordinate as well as in the y coordinate. Del x and del y are very small. Okay, since the point Q is very nearest to P, that's why the x coordinate and y coordinate doesn't change much. Okay, if the x coordinate of P is x, y coordinate of P is y, then the x coordinate of Q is x plus del x, but del x is very small, and the y coordinate of Q is del y, which is also very small. Then what is del x and del y? I know that you guys already know that this is x, and this is x plus del x. Then the del x length is this, that is this length is del x. Okay, if this is del x, then this is also del x, they are same length. And this is y, this is y actually. The y coordinate of P is y, so this is y. This is y, that means this is also y. And this length is y plus del y. Since the coordinate of y coordinate of Q is y plus del y, then this height is y plus del y. Then what is the length del y? The del y is this. So as you can see, we got a triangle here, where only not a triangle, it is a right angle triangle, where PQ is the hypotenuse, del y is the perpendicular, and del x is the base. Clear? Okay. So we got a triangle PQ, let the point be called K, let this point is K, then PKQ is a right angle triangle, where PQ is the hypotenuse, PK is the base, and QK is perpendicular. If this angle is theta, then what is this angle? This angle is also theta. Okay, clear? Since this is theta, this is also theta. Since this is a straight line and x-axis and this line PK, they are parallel, so this is similar angle. You guys already know what is similar angle. So this is theta, this is also theta. So what we get from PKQ, right angle triangle? We get from PKQ, from triangle PKQ, we got, don't forget, we have to study derivative, actually geometric approach of derivative. What derivative gives geometrically. Okay, we have to study that first. That's why we have to do this kind of algorithms. So from triangle PKQ, what do we have got? We have got, this is theta, so tan theta equals to what? Tan theta equals to perpendicular base, that means del y by del x. Since this theta and this theta is same, and tan theta is what? Tan theta is slope of the straight line. So tan theta is slope of this straight line, and from triangle PKQ we have already got the value of tan theta. So what is the slope of this straight line geometrically give? This gives change in del y means what? Del y means change in y coordinate. Since y coordinate of P is y and y coordinate of Q is y plus del y, then what is change in y coordinate? Change means final minus initial. Then final y coordinate is y plus del y. Initial y coordinate is y. Then change in y coordinate is y plus del y minus y, that means del y, by change in x coordinate. This is called change in y coordinate, change in y coordinate, change in y coordinate with respect to x. Del y by del x means change in y coordinate with respect to x. Then you guys might be thinking, then what is the meaning of with respect to x? I know you guys already know that this straight line is of the form y equals to mx plus c. Okay, that means this straight line is represented as y equals to function of x. Since this is a function of x, so y equals to function of x. In this equation, what is the which one is dependent variable, which one is independent variable? Here x is independent variable, y is dependent variable, and y is depending upon x. So if the value of x is changed, then the value of y will be changed. So y is dependent variable and depending upon x. X is independent variable which is not depending to anyone. Okay, fine. So since y is depending upon x, so this thing where change in y happens is due to change in x. So change in y coordinate with respect to x. That means here change in y coordinate happens because change in x coordinate happens. Okay, since change in x coordinate is del x, that's why change in y coordinate is del y. So del y is depending upon del x rather than x, we can say that. So geometrically, what is the slope of the straight line? It is change in y coordinate with respect to x. With respect to x coordinate, you can also say that, with respect to x coordinate. So geometrically, what is the slope of the straight line means? Geometrically, slope of the straight line means change in y coordinate with respect to x coordinate. Okay, you guys clear that? Okay, fine. But now we have to look another problem similar to this. Another problem, if I replace this straight line by any curve, by an arbitrary curve, if I replace this straight line by an arbitrary curve, then what will be the picture? Just draw it. I replace this straight line by any arbitrary curve. let's say I replace this straight line by this curve. Okay, replace this straight line by this curve. You can draw any curve, it doesn't matter. And I consider 2 points P and Q in this straight line. Now I have to consider this P and Q in this curve because I replace this straight line with a curve. So this point is P, this point is Q. Clear? Okay. Then what is the difference? Here PQ is a straight line. PQ is a line segment in a straight line. So this is also a straight line. But here PQ is not a straight line. Okay. Here PQ is a segment of the curve. So PQ is not a straight line. Okay. PQ is a curved line. Okay, fine. So if the coordinate of P is x comma y, then we have to consider coordinate of Q as x plus del x and y plus del y. Clear? Since Q is very near to P, as I already said. Okay. Now watch closely. Now if I join the point P and Q by a straight line, then what is going to happen? I join the point P and Q with a straight line. Then right now PQ is a straight line, this is a straight line PQ, and this is a curved line PQ under that. Then I extend this straight line. I extend this straight line like this, because straight line has no starting point and ending point. This is a line segment. This is a line segment PQ. The line segment is the line segment of which straight line? Is this straight line. Since the straight line has no boundary, has no starting point, no ending point. So this is going to be infinite length. This is also going to be infinite. Okay, fine. Clear? Fine. Okay, fine. So if the coordinate of P is x comma y, then I have to find what is the slope of this straight line. Like that. Here the straight line is PQ, but here the straight line is a curve. We replace this straight line by a curve, and we join P and Q by a straight line. So the straight line will come again. Now the straight line will come again. Okay, like this. Then what is the slope of this straight line? What is the slope of this straight line? We have to calculate that. Since the straight line has 2 points on it, P and Q, and the coordinate of P is x comma y, coordinate of Q is x plus del x, y plus del y. Let me memorize your formula. If AB is a straight line, okay, and the coordinate of A is x1 comma y1, coordinate of B is x2 comma y2, then what is the slope of the straight line? The slope is y2 minus y1, that means change in y coordinate, by x2 minus x1, that means change in x coordinate. If the straight line has 2 points on it, the coordinate of point A is x1 y1, the coordinate of point B is x2 y2, then the slope of the straight line is y2 minus y1 by x2 minus x1. If we apply this formula to this, here x1 y1 is xy and x2 y2 is x plus del x, y plus del y, then what is the slope of the line this line equals to slope of PQ. The slope of PQ and the slope of the whole line are same. PQ is the line segment of this straight line, na? So the slope of the straight line and the slope of this PQ will be same. So the slope of the line equals to slope of PQ equals to what? y2 minus y1 by x2 minus x1, that means y plus del y minus y by x plus del x minus x. That means what? Del y by del x. Like this. Okay, like this. We consider here a straight line, here we consider a curve, and we consider 2 points on that curve, and we join the 2 points by a straight line, and we find the slope of the straight line. So this is similar to this, no issue. Then what is the difference? Why we draw this curve? What is the difference? I approach similarly in first case and similarly in second case. Then what is the purpose of this curve? why I draw this curve? Right now, I calculate the value of the slope of this straight line. Now, what is this? What is this? This is change in y with respect to x. What is the slope of the straight line? Change in y with respect to x. What is this? What is this? What is the geometrical meaning of this? Change in y coordinate with respect to x coordinate. So we found the change in y coordinate with respect to x coordinate in which portion? We considered the change in y coordinate with respect to x coordinate in this portion PQ. The change in we calculate the change in y coordinate with respect to x coordinate in which portion? The starting point is P, the ending point is Q, and we calculate the change in y coordinate with respect to x coordinate in this portion in PQ. So this is change in y coordinate with respect to x coordinate in the portion PQ, in PQ. In PQ, we find the change in PQ. What is the change in y coordinate? What is the change in x coordinate? In PQ, the change in y coordinate is del y, because PQ starts from P, PQ ends from Q. Then what is the change in y coordinate? Y coordinate of Q minus x coordinate of P. So this is change in y coordinate. Okay, what is the change in x coordinate in PQ? X plus del x minus x, so which is del x. So change in y coordinate and change in x coordinate, it happens in PQ. Now, so this is also this is also the same. Change in y coordinate with respect to x coordinate, we find this in which portion? We find this in this portion, that means PQ portion. Now I have to find this change in y coordinate with respect to x coordinate. I have to find this particular value in a particular point. We find the value, we find the change in y coordinate with respect to x coordinate in a portion PQ, in a line segment PQ, or in a curved line PQ. Now we have to find the change in y coordinate with respect to x coordinate in a particular point. So this is the value of change in y coordinate with respect to x coordinate in PQ. If I have to find, if I want to find change in y coordinate with respect to x coordinate in a particular point, say P. So what is the change in y coordinate with respect to x coordinate in P? What is going to be look like? What is the value of change in y coordinate with respect to x coordinate in particular point P? We find change in y coordinate with respect to x coordinate in a particular portion PQ. Now we have to find the change in y coordinate with respect to x coordinate in a particular point. Okay, fine. So I think you already found the target here. So we have to find the change in y coordinate with respect to x coordinate in a particular point, say the point is P. Okay. So for this is the value of change in y coordinate with respect to x coordinate in PQ. Now if we drag the point Q into P, we drag the point Q to P. Q is very near to P. We drag the point Q to P. If we apply this, we drag the point Q to P, then what is going to happen? This is del x. I know that this is del x. Okay. If we drag the point Q to P, then the del x is going to be tends to 0. Since the point Q goes to P, then this change in x coordinate, this change in x length is going to be tends to 0. Okay. So now we can write the change in y coordinate, change in y with respect to x at P. Change in y with respect to x at P. For this, we drag the point Q to P. Then this change in y with respect to x in PQ becomes change in y with respect to x at P. Since Q is, we drag the point Q to P. Okay. If you drag the point Q to P, then the PQ straight line are more and more closer to P. If you drag the point Q to P, then the change in y coordinate with respect to x in PQ, the change in y coordinate with respect to x coordinate in PQ will become change in y coordinate with respect to x coordinate in P, since we drag the point Q to P, since we move the point P to Q to P. So change in y coordinate with respect to x at P equals to what? If you drag the point Q to P, what is the process of dragging? We have to consider del x tends to 0. If del x tends to 0, then this length tends to 0. If this length tends to 0, then Q automatically tends to P. Okay, so change in y coordinate with respect to x at P is limit del x tends to 0, or simply del x tends to 0. I know you guys are already know then what is the process of the limit. Okay, since I am teaching derivative, so in previous chapter also you are comfortable with limit, I guess so. So limit x del x tends to 0, that means what? That this variable is tending to 0. Okay, this value. Okay, if we apply limit del x tends to 0 to this value, this is change in y coordinate with respect to x in PQ, and if we apply del x tends to 0, then this value will become change in y coordinate with respect to x coordinate at which point? At P, since we apply del x tends to 0. If we apply del x tends to 0, the point Q tending to P, the point Q automatically goes to P, and the point Q is automatically goes to P, then this value is change in y coordinate with respect to x coordinate, not in PQ but in P, since we drag the point Q to P. So del y by del x. Okay, this particular value is denoted by dy dx. This particular value is denoted by dy dx. Okay, fine, clear the whole thing. So the change in y with respect to x at P. So we have done this. We already found the value of this. This is change in y coordinate with respect to x at PQ. And if we apply del x tends to 0, then the point Q automatically goes to P. Then this value becomes, if we apply limit del x tends to 0 to this value, then this value becomes change in y coordinate with respect to x at P. And this is considered as dy dx. And this is formally denoted as derivative of y with respect to x at P. This is called derivative of y with respect to x, where d stands for derivative. So what is dy dx? Dy dx means derivative of y with respect to x. Derivative of y, if we say that change in y with respect to x, then there are two cases. One, change in y with respect to x at a particular point, or change in y with respect to x at a particular line segment or a particular portion. But if we call derivative of y with respect to x, then it is considered as the change in y coordinate with respect to x at a particular point. If we not consider the change in y coordinate with respect to x at a particular point, then this is not derivative. Derivative means change in y coordinate with respect to x at a particular point, which is the derivative of y with respect to x. Then what is derivative of y with respect to x? What is dy dx? This is change in y with respect to x at a particular point. Okay, clear? So we don't have to write at a particular point. We don't have to write derivative of y with respect to x at point P. We don't have to write that, because change in y coordinate with respect to x at P is has already specified as derivative of y with respect to x. Derivative means that it is happening a particular point. Okay, the change in y coordinate with respect to x at a particular point. Okay, derivative can't be found on a region, on a portion. Derivative, always derivative, we have to find derivative at a particular point. Okay, so we don't have to write derivative of y with respect to x at a particular point. We just write derivative of y with respect to x. This means the change in y coordinate with respect to x at P at a particular point. Okay, now we have to find we have to find then what is the geometry of this. This is knowing. We already know that this is change in y coordinate with respect to x at a particular point. Then what is the geometry of this? We already know del y by del x means what? The slope of the straight line. The slope of this straight line. This straight line is del y del x. The slope of this straight line is del y del x. Then what is this? What is limit del x tends to 0 del y del x? What is this? What geometrically what is this means? Consider, since we already know that del y by del x is the slope, we apply del x tends to 0 to it. So this is also a slope. Okay, del y by del x is a slope. We just apply limit del x tends to 0. Then this is also a slope. But this is the slope of which straight line? Del y by del x is the slope of the straight line slope of this straight line PQ. But if we apply limit del x tends to 0 to this, then this is also a slope. But slope of which straight line? Now we have to find the geometry. If Q is tending to P, then there is no if Q goes to P, then there is no straight line which cut 2 points of that curve. If Q goes to P, this straight line cuts the curve at 2 points, P and Q. But if Q goes to P, then this straight line only touches the curve at 1 point, which is P. Okay, समझ में आया क्या? So if the straight line cuts the curve at 2 points PQ, the straight line cuts the curve at 2 points PQ. Okay, but if Q goes to P, then the straight line touch the curve only at 1 point. And if a straight line touches the curve only a point, then what is the straight line called? Like this. I don't have the place right now. I guess you already write down the notes. So I just draw it here. If Q goes to P, then the straight line touches the curve. The straight line touches the curve. This straight line touches the curve only at 1 point, like this. Since that straight line touches at 2 points P and Q, but if Q goes to P, then this straight line touches only 1 point of the curve. If a straight line touches a curve only at 1 point, then this is called tangent. I don't know you guys already know that what is tangent or not, but I just elaborate it in this way, that if a straight line touches a curve only at 1 point, then the straight line is called the tangent at that point. So this is tangent at P, and we are worried about then that this is a slope, but slope of which straight line? This is the slope of the straight line PQ, but this is the slope of which straight line? If Q goes to P, then this straight line is looking like this right now. This straight line is looking like this. This straight line becomes this, which is a tangent. So this is the slope of this tangent. This is the slope of this straight line PQ, and when del x tends to 0, then this straight line is becoming this, becoming what? Becoming the tangent at P. So this slope is the slope of this tangent. So we can also say that dy dx, this is what? This is the dy dx. Dy dx equals to slope of the tangent at P. So there is another geometric approach. We can say that the change in y coordinate with respect to x at P, which is dy dx, which is also the derivative of y with respect to x, and we can also say that dy dx is, because since this is a slope, this is the slope of which straight line? This is also a slope. Del y by del x is the slope of PQ. But if we apply limit del x tends to 0, then this is also a slope. But for which straight line? The slope of which straight line? If del x tends to 0, then this straight line cut the curve at 2 points. But if del x tends to 0, then this straight line touches the curve only at one point, and if a straight line touches the curve only at one point, then this straight line is called tangent of that point. So this is the slope of this tangent, because this is the slope. But when we apply del x tends to 0, then we get the slope, and when we apply del x tends to 0, then the straight line becomes the tangent. So this is the slope of that tangent. So dy dx equals to slope of the tangent at P. So there are two geometric approach, this and this, but we have to just, this is very good for out knowledge, but we have to consider, we have to apply some formula for the problems. For that we have to know the formulas. I just want to tell you guys that what is the geometry of the derivative, what is the geometry of derivative. So after that, in next class we just do some mathematics to it. Okay, so dy dx is what? Derivative of y with respect to x, and y is what? Y is dependent variable, which is depending upon x. X is independent variable. Okay, fine, thank you.